Okay, let's look at some examples from 10.4. So in 10.4, one thing that we do is we add radicals. So if you watch the video that went along with this section, in order to add radicals, they must be like terms, meaning that they must be the same index, so both square roots and not cube roots or fourth roots or sixth roots, and the number underneath has to be the same. So both of these are square roots of 5. So if we have 5 of these and then we get 2 more of these, if we want to know how many of these we have, we do 5 plus 2, and that tells us how many square roots of 5 we have, so 7. So if we have, let's say, 3 square roots of 8 plus 5 square roots of 2, these are not alike. So if we want to add these together, then we have to simplify each radical as much as we can. The second radical doesn't simplify any. 2 is a prime number. It doesn't factor. It's not a perfect square. So that one as far as it'll go. But with the square root of 8, 8 is 4 times 2, and 4 is a perfect square. So we can take the square root of 4 and get 2. This number doesn't simplify anymore, so it stays underneath the radical. So for the square root of 8, it becomes 2 square roots of 2, and we still have this 3 out front that's multiplied times that. So you have to be careful, it's not 3 plus 2. This number is multiplied to whatever we change the square root of 8 to. So 3 times, and we change the square root of 8 to 2 roots of 2. So 3 times 2 is 6 square roots of 2 plus 5 square roots of 2. Both of these are square roots of 2. So if we want to know how many square roots of 2, add the coefficients. We have 6, so that gives us 5 more. 6 plus 5 is 11 of those. So that's how we add. The same thing applies if we have letters. If we have 3 fifth roots of x minus 9 fifth roots of x, these are alike because they are both fifth roots of x. So if we want to know how many fifth roots of x we have, we combine the coefficients. We do 3 minus 9. 3 minus 9 is negative 6. So that's how many fifth roots of x we have. All right, let's do this one. Let's do 2 square roots of 2x cubed plus 5x square roots of 8x. So right now, these are not like terms. What's underneath doesn't match, so we need to simplify each radical as much as we can. We have a 2 in front of this one, and let's see if that square root simplifies. We only have 1, 2, so it has to stay underneath, but we have x cubed. And remember, if we're taking a square root, if we have the same factor twice, we can pull that factor out, and then that factor only occurs once, so it has to stay underneath. So this 2 stays underneath because there's only 1, 2. If we have 3 different x's, we can make one group of x's, so put an x out front. We have one x that's not in a group, so it stays underneath. Now if we look at the next one, we have 5 times x out front, and that's multiplied times whatever this simplifies to. On a problem a moment ago, we saw that the square root of 8 simplifies to 2 square roots of 2. We could call 8 4 times 2, or if you get the prime factorization of 8, 8 is 2 times 2 times 2. 2, 4, 8. We're taking a square root, so if we have the same factor twice, that number comes out. If a factor only occurs once, it stays underneath. So that's another way of looking at taking the square root of 8. There's only one x underneath the radical. It doesn't have a buddy, so it can't come out. So it's left there. So let's see if we can put these together now. We have a 2x in front of the square root of 2x. 5 times x times 2 is 10x. And that's also a square root of 2x. So yes, since these are both square roots of 2x, we can combine these. So if we want to know how many square roots of 2x we have 2x of them and 10x more of them. So we add our coefficients together, 2x plus 10x. Well, how do we add those together? They're both x's to the first, so we keep our x and add the coefficients, 2 plus 10. So 12x is how many square roots of 2x we have? Now, occasionally when we do one like this, we end up with the same number underneath, the same letter underneath, but what's out front might not be like terms. So for example, what do we want to do? 12x cubed. If we simplify this one, the first radical doesn't simplify at all. 3 is prime, and there's only one of them. We only have one x, so neither of those factors are repeated, so nothing comes out. But for the 12 we could call 4 times 3, so the square root of 4 is 2. 3 is not a perfect square, so it stays underneath. And as we saw earlier, if we have the same factor 3 times, but we're taking a square root, since we have that factor 3 times and we're taking a square root, we can make one group of x's, and then we have one x that's not in a group. So remember, every time we have a group, that letter comes out. So we have an x that comes out and one x that stays underneath. So these are both square roots of 3x. But notice our coefficients are not like terms. So it is true that to combine these, we add their coefficients. We add the coefficient of this square root plus the coefficient of this square root. But 3 plus 2x are not like terms. Another way we can look at this is they have a common factor, which is the square root of 3x. So we can factor out that common factor, and if we take the common factor out here, we're left with a 3. If we take our common factor out here, we're left with a plus 2x. These are not alike, so we can't combine those any farther. So that's as far as we can go with this. So there'll be several problems of that particular variety. Some of them are a little bit more challenging, but simplify each radical. And if any of them are like terms, then combine their coefficients. Now, the next topic in this section deals with multiplying radicals. Now, we've multiplied single radicals in previous sections. We want to multiply here, just like anytime we have terms inside of a parenthesis and something out front, we distribute. So we're doing the square root of 11 times the square root of 6 plus the square root of 11 times the square root of 10. So since these are both square roots, we are allowed to multiply together what's underneath. So 11 times 6 is 66. Same thing over here. 11 times 10 is 110. Now neither one of those square roots will simplify. If we look at what factors this is, it's 11 and 6 is 2 times 3. So none of those factors occur more than once. Same thing over here. We have an 11, 10 is 2 times 5. So the factors underneath this only occur once a piece. So that's as far as we can break that down. Neither one of those radicals will simplify. Okay, so let's do the square root of 2 minus the square root of 3 squared. Well, how do we do that? If we're squaring something, that means take it and multiply it times itself. There's not we can't just simply square each term. That doesn't work. But what we can do is we can write this factor 2 different times and distribute. So we can do the square root of 2 times the square root of 2, which I'm going to go ahead and call that the square root of 4. 2 times 2 is 4. The square root of 2 times minus the square root of 3. Well, positive times negative is negative. Square root of 2 times the square root of 3. Multiplying two radicals, so that makes the square root of 6. Here, when we distribute those, a negative times a positive is a negative. Square root of 3 times the square root of 2 is also the square root of 6. And then when we multiply those together, a negative times negative is positive. Root 3 times root 3, well, 3 times 3 is 9. Square root of 4 is 2. Square root of 9 is 3. And then we have two of those. We have minus 1 root 6 minus another root 6, so minus 2 square roots of 6. These are alike. Those are like terms. They're not the same number, but they're like terms. So 2 plus 3 is 5. And then we have a minus 2 roots of 6. Now we can't go any farther, even though it's ingrained for us to recognize, hey, 5 minus 2 is 3. That's true, but these are not like terms. One of them is a square root, one's not. So that's as far as we can take that. All right, how about, let's do the square root of 7x times the square root of 7 plus the square root of x. So to distribute, we're going to do these. So that's the square root of 7 times x times 7. Well, 7 times 7 is 49 times x. And we multiply these together. 7x times x, well, x times x is x squared. So we can simplify this. The square root of 49 is 7, but we only have one x, so it stays underneath the radical. We only have one 7, so it stays under the radical, but we have a pair of x's. Anytime we have something squared under a square root, that undoes itself, and that gives us x. These are not like terms because we have different things under the radical, so that's as far as we can go with that one.